K set sail from port P at the same time, so they're both subject to the same time. It's 2 hours though, which is the handy thing. So we know that one H is going at K sails at a speed of 30 kilometers an hour. Okay, so this is the direction of K. So after 2 hours, how far will it be? 60. 2 by 30 gives you 60. Okay. It doesn't tell us the speed of the other one, does it? Doesn't tell us the speed of H, so that's not good to us, all right? Next thing is we can figure out some, Sam. Now, next thing, guys, is it's essentially, do you see any Z's or N's you can use? What angle do you think this one is here, the one I'm hovering over? It's 35. I think that will also make this one 35. Can anybody tell me why? Yeah, the alternate angles, yeah? You got that, did you? Now, nextly, that means that we know that this angle combined is 80. We know that one's 35, which in turn will make that one 65. Yeah. So now we know all three angles. Now, the side I'd really like to know is the distance between the two ships. What side is that? Don't say hypotenuse, opposite, or adjacent, because they don't exist unless it's a right angle triangle. Huh? Sandra, something that's called alternate angles. It's when you have two parallel lines like this. See the way the top and the bottom of the Z are parallel? It means the two angles that are the same. So this angle is the same as this angle here. So that's what we used. How do we know that was 35? It makes a Z with the other 35 on the bottom. See, we knew that was 35 because it adds to 55 to make 90. So because it's in a Z with the other 35, that's why they're both 35. Okay? All right, guys. Sorry, this is just acting weird at the moment. All right, guys, what's the next thing we're going to do? We're going to have the target. You're going to use a cosine rule or a sine rule? Huh? You use sine rule, did you? Okay. All right, guys. So what we said there was that those two angles are the same. They're both 35s because they're in a Z with each other. We're going to use the sine rule. So we're looking for this line here. We call it X. So what's X opposite? What's the opposite? Sine 80. And then what is the... yeah, 60 over sin 65, because you have to go with the length, you know. Okay? Now, what happens to the sine 80? Goes up here, yeah, and then what's below? Sine 65. Throw all that into the calculator. What you get, Daniel? What? 65.2. Does that sound reasonable? Yeah, because 65 looks at a side of 60, which means that a bigger angle of 80 would need to look at a larger side. Again, so that's reasonable. Now, we have to find the speed of the ship. Anybody reckon how we can find that? Yes, we will do distance divided by time in a second, but we should try and figure out what is the... yeah, we should need to use the cosine rule. So let's hope I get this working. Oh my God, this is okay. So what we had there was we had the sine rule. Now, two lads said we can do this two ways. We can do the cosine rule or the sine rule. We'll do it both ways just to make sure we get the same answer both ways. So I'll do the sine rule first. So what can I do when I do the sine rule first? I can do, what's it, 60 divided by sin 65. We need to know this length here, don't we? Because that's how far H went. So call it Y. Y over sine what? 35. Will somebody in class tell me what 60 sine 35 over sine 65 is? What? 28? 38. And lads, what's 38 divided by 2? If he does 38 kilometers in 2 hours, how fast is he going per kilometer? 19 kilometers per hour. Okay, now another thing we could have done was we could have done the cosine rule instead. Okay, so it's important to know that there's more than one option a lot of the time. Okay, so why doesn't that ever work? So what we can do instead is the cosine rule. What's the cosine rule again? And remember? A squared equals B squared plus C squared minus 2BC cos A. Has to be an angle sandwich. Where's the angle sandwich located? No, 65.2 and the 35, yeah? The 60. And will somebody put this into their calculator and square root for the answer, please? We did. We did, but I'm showing you a different way to find out what y is. So what's y squared equal to when you put it into your calculator? 1,000? 400, square root that. Thank you, yeah. 38 either way. Didn't matter what way you did it. You do the sine rule on the right or the cosine rule on the left. It didn't matter. You were going to get the same answer either way. Everybody cool with that? Okay, great. And just pause that. Anyway, we're now on 16, still recording, okay? C and F are two trees at the edge of a lake. So this is tree 1 and tree 2, okay? Sorry, what's it? C and F are trees at the edge of a lake. Great. S is a large rock some distance from it, so S is here. The race committee finds that the land distance C to S, all right, so which one's C to S again? That is 1,800 meters, no bother. Okay, 1,800 meters. Next thing is they measure CSF to be 23 degrees. Okay, and then SCF is 105. So that's 105 there. That gives us the third angle straight away, doesn't it? What's the third angle? 52. Okay, that's great. Now calculate CF, the distance from C to F. Okay, what rule would you like to use on Y? Okay, we're going to use the sin rule or the sine rule, Y. Yeah, and is it a distance question or an angle question? So it's x over sine what? Equals 1,800 divided by? Okay, cross multiply for the answer then. Sine 28 over sine 52, and what you get? 23. Does 23 make sense? Oh, sine 23, so not 28. My 3 looks like an 8, you're right. So it's, yeah, it's sine 23. So what you get when you put that in? 893. Yeah, that makes sense. The 52 degrees looks at 1,800, so the 23 degrees only looks at 893. That makes a lot of sense. Okay. What's the next thing they want from us? The race consists of running from S to C. So you run from S to C, and then you swim from C to F. Find the total length of the race, correct nearest meter. Yeah, you just add them together to get 2,693 meters. A lot easier than I thought it was. What instrument do you use to find CS and describe how it was used? Oh, a trundle wheel. Do you remember that thing in junior cert science where it's a wheel and essentially, sorry, it's like this. It's a trundle wheel, all right. So what happens is, yeah. So you do is you put it on the ground and you have a wheel, and every single time it rotates, it counts a meter. So if you imagine you can stick like a red part, like a dot on it, and then Jesus, group. Okay, let's hope this works. Of course it didn't. So close I was. Huh? I do this all the time. This should work. Control group. And there we go. So for those of you that don't remember it, what happens is you roll it along the ground, and every single time it spins, it counts a meter. So that'd be 1 meter, 2 meters, 3 meters, etc. Okay, that's how you measure the length along the ground. Okay, name an instrument that might be used to measure the angles. Well, you could use a clinometer. Okay, or you could, if you did it in a perfectly straight line, you could always get like a massive protractor in the corner. Yeah. That's if you get a perfect line. A protractor or a clinometer would be the two answers for that. So lads, no, meter six wouldn't do that for you. Lads, you need a trundle wheel. You basically have to go to where the two corners. So if you were to tie a rope along that, you'd have two perfectly straight ropes, and then you just essentially go to the corner that you're dealing with, and then you can measure it out to be whatever 105 or whatever the angle is. So you'd actually just physically measure with a relatively large protractor. Okay, and we are done.